Hi everyone, and welcome to TACoS Day 3. Today is going to be about booleans and control flow, and we actually have quite a bit to cover today. So go ahead and grab your microbit and your micro USB cable, and let's get started. Today we're going to go over a few things. First, we're going to talk about Boolean expressions and their symbols, and then we're going to go over control flow by talking about if statements and loops. We're going to do one mini activity that's going to be in the if statement section of our video. What we're going to do is we're going to use an if statement to create a light that adjusts to its environment's brightness. And at the end of today's video, you're going to use everything you've learned, loops and if statements, to create a simple reaction game. A Boolean expression is a type of statement that always evaluates to either true or false. Let's look at an example. This Boolean expression asks, is 7 less than 10? Because 7 is indeed less than 10, it evaluates to true. You might already be familiar with the greater than or equal to, less than, and less than or equal to symbols. Here's a list of all the symbols we use to create Boolean expressions. This is less than. Then we have greater than, less than or equal to, greater than or equal to, and not equal to. Although less than or equal to, greater than or equal to, and not equal to are easy to write down on paper, they're not so easy to type into a computer. Because many programming languages are typed, you'll often see these symbols used instead. Also, many programming languages use two equal signs instead of just one. That's because the singular equal sign is already being used to set variables, like we saw in yesterday's activity. For today, let's just focus on these symbols. Since MakeCode is a block-based programming language, we're not going to have to type the other symbols. Now that we're familiar with all the Boolean expression symbols, let's look at a couple more examples. How about this one? Does 5 equal 7? Well, no, of course it doesn't, so that expression evaluates to false. The values on each side of a Boolean expression can be numbers, like they are here, or they can be math expressions, like this. This Boolean expression asks, does 7 times 5 equal 7 times counter? And the only time this is going to be true is when counter equals 5. One of the primary reasons Boolean expressions are useful is to help control the flow of our program. Control flow is the path your program takes when it is being run. Often, we want different things to happen when certain conditions are met. For example, later, when we make our automatic light, we're going to want our microbit to turn its lights on when it's dark, and to turn its lights off when it's bright. So, that's going to give our program two different options. Either the microbit can turn the lights on, or it can turn the lights off. If statements are what we use in programming to choose between two or more different paths. There are three main parts to if statements. There's if, else if, and else. If tells the computer to look for a condition, and if that condition is met, then it will complete its task. Else if gives the computer a new condition to look for if the previous conditions were unmet. Else tells the computer what to do if none of the previous conditions were met. Another important thing to know is that if statements don't require else if or else statements to be complete, and they don't have to produce a result. Here's an example. If it is raining, then you should bring an umbrella. If you give the computer this if statement, what do you think it will do if it's sunny? The way this is written, the computer actually won't do anything. You could stop writing here and just let the computer look for rain, or you could write more. You could say, else if it is sunny, then you should bring sunglasses. Now the computer will bring an umbrella if it's raining, or it will bring sunglasses if it's sunny. If it's not rainy and it's not sunny, the computer won't do anything. If you wanted to give it further instructions, you could add else stay inside, which will tell the computer if it's not raining, if it's not sunny, then just stay home. When it deals with if statements, the computer will run through each statement in order, checking for conditions to be met. As soon as it finds a true condition, it will complete that task and then stop moving down the list. Let's look at one more example. Check out this if statement. It says, if it's morning, then eat breakfast. Else if it's noon, then eat lunch. Else if it's evening, eat dinner. Else, eat a snack. Think about this if statement and try to figure out, what will the program do if it's noon? If you guessed eat lunch, then congratulations, you've got this all figured out. Now that we've got if statements all figured out, let's look at an example in MakeCode. So going back to that automatic light idea that we had before, let's use an if statement to turn the lights on when it's dark and turn them off when it's light. In MakeCode, we use the if block. You can find the if block and the Boolean expression blocks in the logic tab. For this example, I'm going to grab my if block and put it in the forever block. Now I need a Boolean expression, so I'm going to go back to the logic tab and I'm going to grab this 0 is less than 0 expression and drag it into my if statement. Light level is a special variable that we can find in the input tab. This variable holds the brightness level that the microbit senses. When I drag that into my if statement, you can see this light indicator show up on the virtual microbit. It shows that 128 is about half light, 255 is full brightness, and 0 is complete darkness. Since I want my microbit to turn the lights on when it's dark, I'm going to set my Boolean expression to say if light level is less than 125, which was about half, then turn the lights on. You can get the LEDs from the basic tab, grab this show LEDs block, and put it inside your if statement. Then I'm going to turn all of the LEDs on, and now, whenever the light level is less than 125, the microbit will turn the LEDs on. You can see that over here in the virtual microbit. I'll make it dark, and there we go, the lights are on. If you're following along in MakeCode, you may have noticed that this if statement does a great job of turning the lights on, but then they just stay there. That's because we need an else block. You can grab an else block from the logic tab, or you can just go here and click on this plus sign to add it to our current if statement. Inside the else block, we'll tell the microbit to turn the LEDs off. The blocks within the else portion of our if block only run if the first condition is false. So, if light level is less than 125 is true, then the microbit will light up. But if light level is less than 125 is false, then the microbit will turn its lights off. I went ahead and flashed my microbit so that I could show you all how this works in real life. And as it turns out, it's pretty dim in the room that I'm in, so my microbit is just staying on. So I went and got a flashlight, but it turns out flashlights don't show up on camera so well. So instead, I went and got a lamp. You can use either of these things to do your own testing at home, but for now I'm going to use my lamp. So you can see it's dark in here, so my microbit is on. But if you turn the light sensor, which is on the front of the microbit, toward the lamp, turn the lamp on, then your microbit will turn off. So what we're going to do in our next activity is we're going to add a dim setting to the microbit so that it has more options than just on or off. This activity is called automatic light, and you're going to use an if statement to create a light that adjusts to its environment's brightness. We want you to try this activity on your own, so I'm going to go through all 5 steps and then invite you to pause the video before we move on. First, what you're going to do is you're going to create an if statement from the control flow example. So if you didn't follow along earlier, you might want to go back and do that. Then, when you've got your if statement, you need to add an else if block by clicking on that plus sign. Then, you're going to need to set your brightness ranges. For this activity, we're going to use 0 to 84, 85 to 169, and 170 to 255 for our ranges. So your if statement is going to end up looking something like this. We need to write the else if block as 2 different statements that are connected together with an and block. Let me show you where to find that in MakeCode. All you need to do is go into the logic tab, scroll down to where it says Boolean, and then grab this and block, and drag it into your else if block. Once you have your brightness ranges set, you're going to go inside the else if block and show the LEDs in a way that makes it dimmer than displaying all the LEDs at once. When you're done with that, be sure to test out your program by downloading it onto your physical microbit. If you get stuck or you want to check your code, head over to our website, go to day 3, and then scroll down to this activity, Once you're there, you'll find this possible solution, but be sure to do your best before you take a look. Go ahead and pause here so that you can see all the steps and try it out. We'll see you in just a little bit. Alright, so I've got my microbit all flashed. Apparently it is dark in here, but I've got my trusty lamp. So I'll turn my lamp on and we'll see the microbit turn off because it's bright over here. If I move back a little bit, we'll get dim lighting. And then if I turn my lamp back off, then it's dark again. Another method that we have to control the path our program takes is by using loops. Loops allow us to run the same blocks multiple times. There are several different types of loops available to use in the Loops tab. Let's talk about a few of them. The repeat loop runs the blocks inside of it a number of times that you specify, which can also be a variable. In this example, a happy face and a sad face will flash back and forth 4 times. The for loop is similar to the repeat loop because it also runs the blocks inside of it the number of times that you specify. However, for loops have a special variable called index. The index value automatically increases at the end of each loop. The loop stops once the desired value is reached. In this example, we display the index value, which starts at 0 and goes up to 4. The while loop will keep repeating the blocks inside of it until its Boolean expression becomes false. In this example, we have a variable called counter, which starts at 0, and each time the loop runs, it's increased by 1. Each time the loop finishes one loop of code, it checks the condition. If the condition is still true, it runs the code again. Eventually, this loop stops when counter has a value of 10 because the condition, counter, is less than 10, will be false. By now, you've noticed that when we start a new program, a forever block is in the editor automatically. The forever block is actually just a loop that runs forever. Any blocks that are within the forever block will continue to execute as long as the microbit has power. This example will show a beating heart on the microbit until it dies. The forever block is very useful. Remember when we put our automatic light blocks in the forever block? We did that so that the microbit would check the light level forever and ever, switching between each LED setting all the time instead of only checking one time when the microbit is powered on. Now that we've gone over 2 control flow methods, we can apply that knowledge to build a game. In fact, most games you play are just a complex combination of if statements and loops. So our game today is going to be a reaction game, and what we're going to do is we're going to have the microbit randomly flash the letters A or B, and then have the player click the correct button. As soon as the player clicks the wrong button, the game will end and the correct number of clicks will be displayed. We'll build our reaction game in 4 steps plus a bonus step. Step 1 is going to be to create 3 variables called symbol, score, and game over. In step 2, we'll add a while loop and if statements to flash numbers on the microbit. Step 3 will be programming the A and B buttons to respond to the user. And step 4 will show the user their score at the end of the game. When we're done with all of that, we've got a bonus step where you can boost your game with new modifications. Step 1. Create 3 variables called symbol, score, and game over. Here I am in MakeCode. I'm going to go ahead and create a new project, and I'm going to call it Reaction Game. Now, we need 3 variables, so go ahead and open the Variable tab and click Make a Variable. Our first variable is going to help us flash random A's and B's on the screen, so we'll call that variable symbol. We need our symbol variable to store a random number between 0 or 1 so that 0 can represent A and 1 can represent B. So go ahead and grab the set symbol to 0 block and drag it into the on start block. And then go into the Math tab and find the block that says pick random 0 to 10 and drag that into the set symbol block. Then change the 10 to a 1, so that symbol will always be 0 or 1. We need another variable to keep track of the score, so go back into the Variables tab, click Make a Variable, and we'll call this one Score. Now let's set score to 0 on start. Our third variable is going to signal Game Over. So go back into the Variables tab one more time and make a variable called Game Over. We'll drag the Set Game Over to 0 block into the OnStart block as well. Step 2. Let's add a while loop and if statements to flash letters on the microbit. Now we need to make a loop that repeats until the player clicks the wrong button. Let's open the Loops tab and look at our options. Since we don't know exactly how many rounds the player will survive, the repeat loop and the for loop aren't going to work, so we're going to need a while loop. Go ahead and drag the while loop into your OnStart block below the variables. Remember that while loops will repeat the blocks set inside of them until their Boolean expression becomes false. So, what do you think we should put into our new Boolean expression? Since we want the loop to run until the game ends, we should probably use our Game Over variable. When it's time to end the game, we can change the Game Over variable to 1, so let's set our Boolean expression so that while Game Over equals 0, we should keep playing. You'll need to go into the Logic tab and grab a 0 equals 0 block and place it into your Boolean expression, and then go into the Variables tab and grab a Game Over variable and plug that in here. So now, while Game Over equals 0, the game will continue. While the game is running, we want our microbit to flash A or B. Remember, we created our symbol variable to do just that. We want the microbit to flash A if symbol equals 0, and B if symbol equals 1. So inside the while loop, we need to add an if statement. Grab an if-else block outside of the Logic tab and drag it into your while loop. Then go back into the Logic tab and grab this 0 equals 0 Boolean and put it into your if statement. Now we can use the symbol variable in our Boolean expression and a showString block to display the letter. We'll set it up like this. If symbol equals 0, then show string A, else show string B. If you run your code now, you'll see that the virtual microbit is displaying either an A or a B continuously. For this game, we want our letters to flash. So, below our if statement, let's use a show LED block to display a blank screen, and then we'll add a 500 millisecond pause to allow time for the player to press the button. We're almost done. You may have noticed that the virtual microbit is only flashing one letter, either A or B. This is because we never actually changed the symbol variable, so let's do that now. You can simply copy the set symbol block from step 1 and add it to the end of the while loop. Give that a try, and then check that your code matches mine. That was a lot of code, but our game isn't quite playable yet. We still need to program what happens when the player pushes the A and B buttons. So let's go ahead, we'll move on to step 3 and do that now. Step 3. Program the A and B buttons to respond to the user. Let's go ahead and grab an on button A pressed block out of the input tab. Now, we want to check if the user has pressed the correct button, which sounds like a job for an if block. So go ahead and grab an if else block and put it into your on button A pressed block. Then we'll need to go back into the Logic tab and grab this 0 equals 0 block. Remember, we set symbol equal to 0 when the microbit is showing A. So let's go into the Variables tab and check for if symbol equals 0 when they pushed A, then they pushed the right button. Let's let the user know that they pushed the right button by going into the Basic tab and showing them a check icon. We'll also need to increase their score by 1, so go into the Variables tab and grab this Change Variable by 1 block, and then set the variable to score. So now, if symbol equals 0, which is the same as A, they've pressed the right button, so they get a check mark and their score increases by 1. If they didn't push the right button, then let's show them an X icon. There's one more thing we need to do if they didn't push the right button, and that is ending the game. In order to end the game, we'll need another variable block. We'll use this change game over by 1 block, and it's actually already set to the right variable. Because remember, when we set up our while loop, we said while game over equals 0, the game goes on. But while game over equals anything other than 0, the game will stop. So if we change the game over variable by 1, the game will end. Now we need to do all of these things, but for the B button. Go ahead and pause here to take a moment to do that. When you get back, you'll have an opportunity to check your code and test your work. Great work! You've coded an entire game. I've moved my code blocks around so that everything's on the screen at once. We're going to test our game, and if you find yours isn't working the way that you think it should, you should check all of your code and make sure it matches mine. Okay, let's test it out. So I'll click the play button down here, and then I'll click a B, A, B. Cool, it seems to be working. I'll do one wrong. I'll click an A, I got the wrong one, and the game will end. Mine seems to be working great. However, we never told the player what their score was. So at the bottom of our while loop, we should add a show string game over, and then we'll add a show number and set that to show the score. Bonus step: boost your game with modifications. We have a couple ideas for extra items that you can add, so you can try these things or you can try other things. Really, the possibilities are endless. But here are our suggestions. You could add a symbol type for when both A and B are pressed together. You could add a symbol type for when the microbit is shaken. Maybe you want to shorten the pause time to make it more difficult. You might want to find a way to end the game if a player doesn't press anything. And it might be a good idea to find a way to reset the game after game over. The one thing that you should definitely make sure you have is the reaction game working. Make sure that your code matches mine. You might want to go back and just double check everything because we're going to use this game in tomorrow's activities. That's everything I have for you today. Today we went over Boolean expressions and control flow. We talked about if statements and loops, and then we made an automatic light, and we finished the day off with this reaction game. Come back tomorrow for day 4. I'm so excited for day 4 because we finally get to play with our joystick bit. I'll see you then.